Alright, so now let's try an analog input on the Arduino. So we're going to use today a very standard analog input device called a potentiometer. It's this kind of knob that you would normally see on the front of a stereo. And we turn this and the wiper moves just like the potentiometer that we drew in the introductory video to this section. And notice on the bottom, here are the three connections. So the one on the left, which is right here, this one is one side of the wiper. The one on the right is the opposite side of the wiper. So between here and here, inside in the circular package, there's actually a semicircle of resistive material. And as we turn the knob in the center, back and forth, this third connection in the middle is wiping from one extreme all the way around to the other. So if I turn it all the way counterclockwise, the connection is now from the center to the left. If I turn it all the way clockwise, the connection is from the center to the right. So I've soldered on a little bit of header onto my potentiometer to make it easier to insert in the board. But a normal one, all you have to do is just rock it back and forth a little bit until it wears out a little bit larger hole in the plastic of the breadboard. So pick a spot. I'm going to put it in the first position right here, like so. So the first hole here is going to be the left side of the wiper. And then, because the resistor is built in here, this is really pretty much the simplest circuit you will ever build. All it is three wires and the resistor that's inside the potentiometer. So first of all, on the left side, let's do the ground. So over here on the left, we can connect across to our ground bus, like so. And then on the right, we'll connect to power. So if we go all the way left, we're going to go to 0. If we all go all the way right, we're going to get full value, 5 volts. And if I go right here in the middle, make sure I get the middle, that's going to be my analog input. And the analog inputs on the Arduino are, of course, on the bottom right corner, and they read left to right. So I'm going to start with A0 right there. And that's literally the entire circuit. So there's a ground, there's power on either extreme, and there's the signal line in the middle going to A0. So now let's double check for a short circuit. Is there ever a direct connection between ground and 5 volt power? Our only path comes out of ground here, goes through the potentiometer here, and then to the 5 volt cable here to 5 volt bus. So the potentiometer is always in between. And remember that the wiper is only wiping the middle input, which means nothing you do on the wiper, turning the knob back and forth, is affecting the connection between here and here. The full value of the potentiometer, which in this case is written on the front here, this one is a 10K potentiometer, so it's 10 kilo ohms, just like the 10K resistor we use for the pull-up resistor, but this one can vary. So there is always 10K of resistance between black and red. No way to have a short circuit. All right, let's plug it in and write a quick little program so we can see it work. So let's start with a void function setup and a void function loop. We've seen this before. Let's define some stuff up here. Let's do a constant integer pot is assigned, and now we have to tell it that we have A0 instead of 0, 1, 2, 3, 4, 5, 6, 11, 12, 13, because we're now on our analog pins. Well, how do we tell it? Well, we literally type capital A, 0, semicolon. And the Arduino software actually turns that A0 into, I think, probably the number 14, because it's the next number after 13, which is the last of our digital inputs. But it doesn't really matter. All we have to do is type A0, and it works. All right, so our potentiometer is going to be here, and we'll do things the proper way. So we'll say integer pot value is assigned 0. So we're making a variable that's going to hold the value from our potentiometer after we read it. Down here, we're going to start serial communication, serial.begin 9600. And then down in the loop, we're going to do 3 things. So the first thing is we're going to read that analog input and store it in our pot value. So pot value is assigned, And before we did a digital read that gave us a 1 or a 0, this time we're going to do an analog read of pot. So we're going to take a value, analog value from pot, which is pin A0, and we're going to assign it to the variable called pot value. Then we're going to print it, serial.println pot value, and then we'll do our delay. So very similar to our digital input program, except that we're doing an analog read and we had to use A0 instead of just a standard number. Let's go ahead and upload that and we'll see what we get. Hey, that looks different. It's not a 0 and it's not a 1. Notice that it is fluctuating slightly. And this is normal in analog values. It is difficult to get an analog value that stays exactly at a particular value, unlike the digital ones with the pull resistors. So if I turn the knob all the way counterclockwise, I can get a stable 0. And the signal line here is going through the center of the pot, the wipers all the way to the left, which means we're connected through this wire to ground, and we get a stable 0 value. As I move it to the right, I'm going closer and closer with the wiper toward 5 volts. So the more voltage I see, the higher number I get. How high does it go? Well, let's see. It goes not to 256. I'm actually able to get to 1022-ish, 3-ish. So the maximum value we'll actually generate is a 1023. And you'll see it occasionally jump through there. So it goes from 0 on one end to 1023 on the other, which is 1,024 values. Remember our analog write for the LED went from 0 to 255, and that was 256 values. It's because it was an 8-bit number. So it was using 8 bits to store a number, which gives us 256 values, or 0 to 255. The analog input portion of this chip up here works in 10-bit, which means 2 more bits get us 2 more orders of magnitude in binary arithmetic, and that comes out to 0 to 1023, which is 1,024 values, 10-bit. So if we go somewhere around 512-ish, that will actually be the middle point of the marker or the wiper. And we're kind of equally between, we're halfway between ground and 5 volts, which means that input is actually seeing 2.5 volts. And this whole circuit we have built is literally a voltage divider, but with a variable resistor. So that as we turn the knob back and forth, we are varying the voltage, we're just seeing it as a number from 0 to 1023. Any other sensor you use, any other analog device you hook up to an Arduino, anything that isn't digital that's analog, is basically going to do the same 3-wire circuit. This ground and power and signal circuit. They all work in exactly the same way. The sensor itself is some sort of voltage divider, and it basically makes a selection between pure ground or 5 volts or somewhere in between based on what it's sensing. What this is sensing is the mechanical position of the wiper. And in a typical robot, if you have, say, an elbow joint and an arm, and the motor is moving that arm back and forth, mechanically inside connected to that will be a potentiometer like this. And that potentiometer is telling the computer that controls the robot what position is the arm actually in. I know the motor says it's all the way to the left, but are you really all the way to the left yet? So it's actually a very common sensor to have on something like a robotic arm. As old school as it seems, you'd think, okay, I'm not building a radio, why do I need a volume knob? But it has its uses. So we've seen how the analog input works. We've seen that it goes from 0 to 1023. We just get there so close. Every once in a while we get 1023 in there. Trust me. But here's something interesting. Let's now combine this circuit with the circuit for an LED and see what problems it causes when one device is 10-bit, the input, and the other device is 8-bit, the output. We'll take a look at that in a next video.